Hello there, my name is Mike Schrute, and I'm an actuary and also a very avid Mathematica user. I've been using Mathematica 8 for over 10 years, and I would really love to make a video series to demonstrate both its very powerful feature and its ability to solve very realistic actuarial problems to help those who are involved in the field, as well as having those ambitious students with an internship. So I thought the best way to really illustrate both its feature and the underlying principles is to walk through certain very well designed actuarial problems. And here's a problem taken on the topic of deductible and co-insurance. Before we start, I'll explain basic meaning of deductible. Essentially, an insurance policy has a deductible when your claim incurred is below a threshold amount. No payment will be paid. So if the deductible is $1,000 and if your claim is $2,000, it will only pay you the second $1,000 as the first $1,000 is deducted. And another concept related to this is a co-insurance. So a policy with $1,000 of deductible and 80% co-insurance will pay you only $800 because that is 80% of the second $1,000 after the deductible. So with that, those basic principles and assuming very basic probability knowledge, we can look at this rather interesting and a little complicated example. So we have a professional stuntman who repairs his motorcycle every year, and as you can see on the screen, we have two parameters, theta and alpha, to define the loss distribution, which is Pareto distribution. This can be obtained really from the SOA table of distributions if you're taking the North America exams. And Michael has to pay the deductible himself for the first $1,000 and 20% between $1,000 and $6,000, and he has to pay entire cost above $6,000 until he pays $10,000 in the out-of-pocket repair cost for each year. And he has to pay 10% still for the remaining cost. So a very quick question can be asked is, so if you have to pay $10,000 out of pocket, so what is that amount? As it turns out, a lot of people get that calculation wrong, so no matter what you do for the remainder of the calculation, you will not get the correct answer. So if you pay the $1,000 deductible and you have to pay 20% of $5,000 range, as in the condition 2, you already paid $2,000, meaning you have to pay additional $8,000 between 6,000 and X, so X is naturally 14,000. So I'm rather happy with my own method here. You may not like it, but I can tell you it's maybe a little intertwined, but it's really fast and it's really working very well. So here is the method. If you can draw a timeline, unfortunately I'm a little too lazy to draw here. The Mathematica draw tool is Ctrl-T, but I'm not going to draw it here. But the formula is essentially it's going to be the following. That so the question is, what's the expected annual insurance reimbursement, meaning the cost paid by the company. So this policy design is based on the expectation of your loss. But this feature is richer by the Michael's actual policy. So Michael is actually going to be taking that less because he's going to be paying the first deductible, and that's very naturally gives you a deductible D, which is 1,000, and on top of that you have to subtract 20% of that design because you're paying 20% of the amount between 6,000 and 1,000. In expression, it would look something like this. And still, when it's not quite done yet, as you have to pay the whole thing between 14,000 and 6,000. Again, 14,000 is a amount that we just calculated in order to hit the 10,000 out-of-pocket repair cost threshold. And that gives you 14,000. And finally, you still have to pay 10%, as Michael, of the remaining repair cost. So you might say, oh, this is such a lame policy, because it's simply not giving the a very easy to understand loss coverage. Yes, indeed. But after all, this is just really an exercise question for us to get to understand deductible and co-insurance. So you will eventually end up with this mathematical expression, and that's really a translation of the problem. So you are going to calculate this. And what is this? In Mathematica, it's really two lines. First, you define this function. Well, this is the minimum of x and a number of Pareto distribution. Again, this function can be looked up from the distribution table available for the SOA exam, and plugging all you need to do is simplifying this, maybe using Mathematica simplify command, and plug in the numbers. For the sake of time, I'll not demonstrate, but after these two lines of code, you hit Shift Enter, and that will give you the number, which is 27,000, which is exactly the correct answer. So Michael, in fact, his expected annual insurance reimbursement will be roughly $27,000. A quick reality check is to see the expected value of a Pareto, two-parameter Pareto distribution is theta divided by alpha minus 1, which is $5,000. And indeed, your expected annual insurance under this very mean policy should be significantly less than 5,000. Indeed, is 27,000. So that concludes our first tutorial on deductibles and co-insurance.